Here we will be examining the HP3456A digital voltmeter. In this series we will be looking at a unit that fails with an overload error, and error code 4. These errors are a common problem with this unit. Along with fixing this error we will perform a few upgrades along the way. In this first part of the series we will perform the self-test, and see what the symptoms are. Let's fire the unit up and perform a baseline of the current draw. Power up, ensure nothing is connected to the terminals button is set to front, and the guard button is set to low. Press the test button. We should see all digits and elements of the LEDs light up intermittently. Let's look at the power draw with our Variac. Looks to be drawing around 80 mA at 235 volts AC. After a few minutes our meter starts to present the failure code 4. When we take the unit out of test mode by hitting the test button, we see the overload displaying on the meter. Clearly this meter has an issue. Let's take a look at the service manual to see how to resolve this problem. Go to Section 8. Troubleshooting. Go to Section 8-334, Self-Test Troubleshooting. Down to 8-339 Test number 4. This is the error 4 that our unit exhibits. The description tells us it's either the in-guard logic, analog digital or DC volt circuitry. It also goes on to say the overload is often displayed during this failure. This sounds like our fault condition. We are directed to Service Group B. Open Service Group B. In-guard logic and AD. Go to Section 8, B, 8, Overload Failure or Constant Zero. Let's perform this test. Let's power down and unplug the unit. Unscrew the top cover. Remove and set aside. Unscrew the internal top cover. Remove and set aside. Unscrew the bottom cover. Remove and set aside. Unscrew the internal bottom cover. Remove and set aside. Let's refer back to 8B8.2 of the service manual. We need to change J35 jumper on the A30 board. The A30 board is on the bottom of the machine. The jumper is in the run position on pins 1 and 2. Let's change jumper to pins 2 and 3. Repower the machine. We note the overload has gone. Leave the machine running for a few minutes to see if the error returns. Hit the test button, again wait to see if errors return after some time. It looks like the issue has gone. Point 4 explains, if the instrument is now working correctly, the overload circuitry is at fault. This seems to be the issue. Let's check C410 on the A20 board, as described in point 4. The A20 board is located on the top of the unit. Let's test the C410 in circuit. It measures 4.2 nanofarads. This is close enough to the specified 4.7. Point 4 suggests if C410 is not shorted then the probable cause is U409. U409 is also on the A20 board. Let's remove the A20 board. Unlock all 7 standoffs. Lift the 3 wires from their pins, located toward the side of the unit. Gently lift the board from its connectors, using the standoff pins and connectors as a handle. Some jiggling will be required to get the pins to release the board. With the board now safely removed we can look to desolder U409. Flip the board over. Desolder U409. Remove U409. Insert a 14-pin dip socket. Solder the socket in place. U409 is an LM339N, a quad differential comparator. Insert the new IC. Although not strictly required, we will also replace C410. Desolder C410. Out of circuit it measures good at 4.27 nanofarads. We will replace C410 with a 472J, a 4.7 nanofarad 100 volt metal foil capacitor. Install the new C410. The cap installed. Whilst we have the A20 board removed, we will perform a few upgrades. Let's test and replace C701, a 150 volt 1 microfarad capacitor, listed as a tantalum and can be problematic in this unit. We will replace this with a 1 microfarad 250 volt metal poly capacitor. We desolder one leg to measure the cap out of circuit. Measures high ESR of 5.8 ohms. The replacement should fit nicely in its place. Solder in place. Installed. Before we reinstall this board, we will clean the connector pins. Use a good electronic cleaning solvent such as Servosol. Spray onto a lint-free pad and gently wipe the pins of the connector. Spray solvent onto the board connectors also. Allow time for the solvent to evaporate or air dry. Reinsert the board. Take care that all the terminals are aligned. Double-check all terminal blocks are seated correctly. Reinstall the 3 wires into their respective pins. Push down on the standoffs, ensure they lock in place. Back on the A30 board. Move J35 jumper back in the run position, pins 1 and 2. Reinstall all the covers, and start the unit up. Looks to start okay, and our test is passing. As you can see from our monitoring over 6 hours, measuring a voltage source. The unit is now functioning perfectly. This completes the clip. I hope you found it informative. Thank you for watching. Whilst this is an old meter, it is well worth keeping in the lab, particularly if you perform the upgrades we will suggest in this series. We will be producing a number of upgrades to this unit, so stay tuned for further clips in the series. Please subscribe, like and comment, your feedback is important.